Hello everyone, welcome to Indomitable Tech. This is your AIML consultant Shaunak, and in this particular video we'll be focusing on clustering models. So AIML models which deal with clustering will be primarily focusing on kmeans, DBSCAN, optics and affinity propagation. DBSCAN stands for density based spatial clustering of applications with noise, and optics is built on top of DBSCAN. Optics stands for ordering points to identify clustering structure. So we'll be primarily focusing on these four ML models. The dataset that we'll be focusing on is on Kaggle. The link I have mentioned at the very top of the notebook. So this is the dataset that we'll be referring. This is how it appears: ID, sex, marital status. These are the column names. You can download this dataset from Kaggle. There are in total 8 columns in this particular CSV file, and we'll be checking which columns to use and which columns to not use. This notebook, I have kept it on GitHub. The link for the GitHub repository is in the description of this particular video. There are, as always, 2 versions of this notebook. One will be the solved version and the other will be the unsolved version. The unsolved version will appear like this, that is before how it is appearing right now, that is before the solving, and it has commented out instructions. So when you are solving the notebook on yourself as a practice, you can read the comments and execute the code. So read the comments, write the code, execute it. So basically the unsolved version is for you to practice. If you have understood this video, I would suggest you to first go with the unsolved version. And now let's begin with this particular notebook. As always, we'll be solving this in 4 steps. Step 1, importing the libraries. Step 2 is reading the dataset and exploring it. Step 3 is cleaning and pre-processing the dataset. Fourth one will be building and evaluating the models. The metric that we are going to use for evaluating the model is silhouette score. So let us start. We will import pandas to read the data frame. So import pandas as PD. We'll use numpy for numeric calculations. So import numpy as NP. For clustering, we'll be making use of 4 models. We'll import that from sklearn, from sklearn.clustering. Import kmeans. So it is not clustering, my bad, it is cluster. Import kmeans, then DBSCAN, then optics, then cluster optics DBSCAN, and finally affinity propagation. This cluster optics DBSCAN, we will be using this in optics to find the predictions. Then standardization and normalization, we will import that from sklearn as well, from sklearn.preprocessing. Import standard scaler and normalize. We'll use silhouette score as the metric. So from sklearn.metrics, import silhouette score. And other libraries that we'll be using is matplotlib to plot the graph and nearest neighbor. So these 2 things, matplotlib and nearest neighbor, will be making use to calculate epsilon value. Epsilon value will be useful for us when we are building DBSCAN and optics model. So let me quickly import them. Import matplotlib.pyplot as plt, and from sklearn.neighbors, import nearest neighbors. Okay, now I'll execute it. Okay, that is done. Then let us read and explore the dataset. So this is the path to the file which has the data. So let me read it into raw df. So that is the name of our data frame that we'll be reading the data into. So pd.read_csv path. And if you want to see how the first few rows appear, let us see the first 3 rows. This is how it appears: 8 columns, but the first one ID has no significance, so we can drop that particular column. So let's start with cleaning and pre-processing the data frame. So remove unwanted column. So id is the unwanted column, let us remove that. So drop name of that column, access equal to 1 and in place equal to true. Execute it. Now let us drop duplicates and see if there are any missing values. So raw df dot drop duplicates, in place equal to true. So this will remove any duplicate values, and now let us check if there are any missing values. Raw df dot is na dot sum. So since all the values are appearing 0, so there are no missing values in our data frame. Now let us make a list of numerical and categorical columns. So this list will be helpful for us when we are scaling and normalizing the data, because we can only scale and normalize the data on the numerical columns. So on analyzing the data set, we see age and income are the only two columns which are the numeric columns. Rest are categorical columns. Let us make a list of the column names. Numerical calls equal to age and other column is income, and categorical columns equal to, I'll use list comprehension, column for column in raw df dot columns. So raw df dot columns will give me list of all the columns of raw underscore df data frame if call not in numerical column. So I'll select all the column names except for these two. Now that is done. Now I'll check data types of categorical columns. So ideally the data type for categorical column should appear as category. So raw df dot info, this is how you see the data type. So if you see, all the data types are appearing as integer 64, but ideally the data type for categorical column should appear as category. So let us quickly fix that. So let us iterate over every column name. So for call in categorical call, raw underscore df call equal to raw underscore df call dot as type category. This will convert all the data types of categorical columns to category. So if I execute, so if you see, all the data type is now appearing as category instead of int 64. Then let us scale and normalize the numerical data. So let me start with scalar equal to standard scalar. So this will create the scaling object, and then raw underscore df numerical columns, as we are scaling and normalizing only over the numerical columns. So scalar dot fit underscore transform raw df numerical columns, and let us normalize equal to normalize raw df numerical columns. Okay, now that scaling and normalizing is done, let us one hot encode the categorical columns. So it will convert the data frame into a sparse matrix. So df equal to pd dot get dummies and raw df categorical columns, and let us now add the numerical columns to it. Raw df numerical columns dot copy. So that is done. I'll show you how our final data frame appears. Let's see the first 3 rows. Okay, sorry, my bad. So this should not be raw underscore df, it is, I made a mistake over here. It should be df of numerical columns, because we are adding the numerical columns. Now if I execute, this is how our data frame appears like. All the values of categorical columns is either 0 or 1, and numerical column values ranges between -1 and +1. Now let us start building the models. Let's start with kmeans. So guys, in kmeans we are passing the number of clusters, and the model will then build and will be using silhouette score to evaluate the model. So for cluster size in range, so let's iterate over, let's say 100 to 200 for cluster size in range 100 to 200, and let's jump over, the step size will be 10. So km equal to k means number of clusters equal to cluster size, and then let's fit the model, and then let's make the predictions. Km dot predict df, so it will tell what cluster size each row belongs to, so what cluster each row belongs to, sorry. And let us calculate the silhouette score. It is df, then the predictions, and then let's say sample size as 1000, because total data frame consists of 2000 rows, so let's take sample size of 1000, and then random state as 42, and let us print cluster size equal to this cluster size, and then score equal to score. And one more thing, let's select best cluster size. Let's start with 0, and best score as, let's start with none, and ultimately let us put the condition, if let's say score as 0 and best cluster size as none, because cluster size is starting from 100. So if this score is greater than best score equal to score, and best cluster size equal to this cluster size, and print f string best cluster size is this best cluster size, and then best silhouette score. Best silhouette score is this best score. Now let us execute it quickly. So this is how the values are appearing for this cluster size, and the best cluster size that we have got is at 160, the cluster size of 160, and best silhouette score is 0.6015. So that's all for k-means. Now let us move on to DBSCAN and optics. So DBSCAN and optics are based upon epsilon. Epsilon is nothing but radius of the circle that it plots to identify the near points. So to calculate this epsilon, we can iterate over different epsilon values, but instead of that, what we will do is use nearest neighbors technique. So let us assume the sample points as 10 and its neighbors as 10. So let us build nearest neighbor model. Nearest neighbors, n neighbors equal to 10, and let us fit our data frame on this nearest neighbors model, neigh. Let us save that in neighbors, nn.fit df, and let us calculate distance indices. This should be distances because it will be multiple distances, is neighbors.kneighbors, and here you have to again pass in the data frame. And now that we have got the distances, we will plot the distances. So plt dot figure, fixed size, let's say 5 will be the width and 3 or 2 will be the height, and plt dot plot, and here we will pass in sorted version of distances. So for sorting we will use np.sort distances over all the rows, and let's take the last column. So since it has 10 columns from 0 to 9, so 9th will be the 10th column, as pandas Python starts with 0 index. So plt.plot, and then plt.x label we will say values, and plt.y label we will take it as epsilon. Now let us plot. So this is how it is appearing. So we have to take the elbow point. So near about this point we are getting the elbow. So it is somewhere in between 0.5 and 10. For our understanding, let us keep it as 0.75 for ease. So epsilon, I'll say it as e equal to 0.75. So we will say epsilon referring to the plot above. Elbow point is at 0.75. So epsilon e equal to 0.75. Okay. Now let us build DBSCAN. DB equal to DBSCAN and epsilon equal to e, this epsilon, and minimum samples, let's keep it as 10. Now let us fit the model. db.fit df, and then let's make predictions. Pred equal to db.labels, and then if you want to see the clusters equal to count of, that is the len of np.unique of these predictions. So this is how we'll get the clusters. And if you want to see the score, silhouette score, you can do that as well. df, then pred, and sample size 1000 and random state 42, the same that we did above. And let's print the output. Print cluster size and epsilon value is e, then cluster size is cluster, and score equal to score. Let me execute it, and this is how it is appearing. Epsilon value 0.75 that we calculated above using this plot. Then cluster size is 38 and score is 0.468. So silhouette score lies between -1 and +1. -1 means the model is worst and +1 means the model is best. So clustering that has occurred is best. So any value above 0.25 we can say the model is relatively better. So 0.468 we can say for 38 cluster size the model is built okay. Let's move on to optics. So similar to DBSCAN, we are making use of epsilon in optics. So op equal to optics, and if you see the parameters, hit shift tab if you are in Jupyter Notebook. So you can see all the parameters: minimum samples, max EPS, metric. So in this particular case we are going to select minimum samples as 10, and then op.fit df, and then we will take the predictions using cluster, optics, DBSCAN. And then again, if you see the input parameters, it is reachability, core distances, ordering, and EPS. I'll just copy paste it. All these values you will get from OP. So reachability equal to OP dot reachability, core distances equal to OP dot core distances, ordering equal to OP dot ordering, and EPS equal to E that we calculated here above. So for reading purpose I'll just put it one below the other, and then now we have got the predictions. Let me calculate the clusters. Cluster equal to count of np dot unique pred. Now we have got the number of clusters, and ultimately I'll print our findings. Epsilon is E, then cluster size. Cluster size is cluster, and then score equal to score. Score I forgot to calculate. Score is the silhouette score, and it is df, then the predictions, then sample size of 1000, and then the random state of 42. And if I execute it, optics takes more time than DBSCAN, so it is time consuming. So I'll just fast forward it to the point when the calculation gets completed. Okay, so the calculation is completed, and optics has also predicted it as 38 clusters, and score is 0.466642. So optics compared to DBSCAN, so the score is a bit low compared to DBSCAN. Now let us move on to the final one, affinity propagation. So in affinity propagation, our main parameter that we have to focus on is the damping. So damping varies between 0.5 and 1. So let us iterate over the different values of damping and select the one which gives the best silhouette score. So for d underscore val, so that will be the damping value. So for d underscore val in np.a range, we cannot use the range over here because we are iterating over float values. So 0.5 and ending point will be 1 and step size will be 0.1. So d underscore val equal to round d underscore val. So I am just rounding it out to 1 decimal, d underscore val. Now let us build the model. Affinity propagation, damping equal to d underscore val. Now let us fit the data frame to the model, ap and dot fit df, and now let's make the prediction, pred equal to ap dot predict df. And then now that we have the predictions, let us calculate the number of clusters. Cluster equal to length of np dot unique, and then let's calculate the score, silhouette score, df pred sample size equal to 1000 and random state 42. So it gives the same reading when you are using random state as 42. And let us print the values. Print damping d underscore val, then cluster size equal to cluster, and then score equal to score. And similarly to what we did in kmeans, that is giving best cluster size and best score, since we are iterating over multiple values of damping, so let's give the value best d val equal to, for starting let's give it 0, and because d val is starting from 0.5 anyways, so let's give it 0. And cluster size and score, best score. So if score greater than best score, best score equal to score, and then best dval equal to dval. And ultimately let us print best damping value equal to best dval, and score equal to best score. Now let us execute it. This will also take some time, so I will fast forward it to the point when this training is completed. Okay, now that the training is completed, so if we see the results, so best damping value is 0.8 because it gives the maximum silhouette score. So and total number of clusters as per affinity propagation is 84. Affinity propagation is best used when you don't have an idea of the number of clusters in your particular data set. So at that time affinity propagation is widely used. So to recap what we have discussed in this particular notebook, we saw the data customer clustering, which is on Kaggle. The link is given in this particular code block at the very beginning. We saw 4 machine learning models: kmeans clustering, DBSCAN, optics, and affinity propagation. In kmeans, you have to give the number of clusters, and the model will then classify the given observations into those many clusters. In DBSCAN, optics, and affinity propagation, you don't have to provide the clusters. DBSCAN and optics makes use of epsilon value. Epsilon is nothing but the radius of the area in which it is identifying the minimum samples. Then ultimately in affinity propagation, we are considering damping, and this damping helps us build the model, and based upon the best score that we are getting, silhouette score, will be classify that value as the damping score. We also get cluster size as well. So affinity value, if you don't know the clusters in your dataset, use affinity propagation. So that's all for this particular video. There are other videos which deal with regression, clustering, then classification, anomaly detection, deep learning, and also time series forecasting, along with other machine learning videos. And if you are not into machine learning and data science, you can also refer to other videos dealing with data visualization, fast API, etc. If you have any queries, please let me know in the comments below, or you can also send me email on my email ID I have mentioned at the bottom. If you want me to create any particular video related to Python, data science, or machine learning, I can do that as well. Also, if you want to collaborate on any particular project, you can also send me an email, and I'll see you in the next video. Thanks.